So when you are done dividing, you can write a division statement. Okay? This is on page 4, the division statement. Now, what this means is the example that we just did. I'll show you with the example that we just did what a division statement is. We took this, divided by this, and got this with a remainder of 8. If we wanted to write that as a division statement, I'm going to erase this here for now. We could say that, and just like when we wrote before about our factoring, that this thing that we had to start with is going to equal, slide this over a bit, it's going to equal x minus 1 times by 2x squared plus 5x plus 3. And that would be what it would equal if it was perfect. But we have a remainder, so we write our remainder at the end as plus 8. So the way that I remember a division statement is I remember this is my polynomial that I start with. If we label what different things stand for, what you're dividing by is called a divisor. So your polynomial is equal to your divisor. Your answer is called your quotient. This always makes me think of ice cream. dq. And then plus your remainder. So our division statement is always dq, our polynomial is equal to dq plus r. Yes? Yes, if the remainder was negative, you do plus negative 8, which is the same as subtracting 8. So this is what is listed here as the division statement. Polynomial equals your divisor. This is your divisor. Quotient plus your remainder. Awesome. So now we can go to example 2. And we are going to divide this by x plus 2, but this time we're going to write the division statement. So I'm going to let you do the first work. Notice how everything, this does add one new thing. We don't have an x squared. Okay? We don't have an x squared in this example. So we have to write a 0 so that our columns match up. So you need to have a column for every power. And if something is missing, you need to write a 0. You do this in numbers, right? If you have 100 plus 5, do you write that that's equal to 15? 100 and 1, 5? No, you have to put a 0 in between to hold that place. We need the 0 in here to hold that place value. So in the same way in algebra here, when we're doing long division, we need a 0 where the x squared is to hold that place. Sometimes you're going to get a question that's going to have a lot of things missing. You might have more than one 0 that you will need to add. So now we've learned 2 important sort of setup processes for long division. It has to be in the right order. And if something is missing, you need to add a 0. Okay, so you get to start by doing the long division. So how did you do? Okay. So you have to check the plot. If you made a mistake, you made a little mental math mistake, usually with the subtracting. You wrote the negative 70, just like I said, when you get close to the end, you get so excited. And I color-coded it so you could see where each step repeated itself. So we do the green first, then the black, then the purple, and then the diarrhea color. Sorry about that. Okay, you see it as gold. Well, that is such a more positive way of, yes, gold rather than diarrhea. Yes. Can we not use gold next time it hurts your stomach? Okay, we'll try to. White works. So we can now write our division statement. Yes? Ooh. All the rest, but you made one mistake and then you actually made two mistakes. You made one mistake and then you made another mistake that countered out your mistake. Nice. Yeah, you would still lose some marks there in the end. So now we can write our division statement. So what have we found? Now, our polynomial was 3x to the 4 minus x cubed. And when you're writing this out, minus x cubed, not 3x, you don't have to write the 0x squared in here now. You can just write it out just like it appeared. This polynomial, this is our polynomial, it's going to equal, we're dividing by x plus 2. We got as our answer 3 minus 7, 14 minus 25. 3 minus 7, 14 minus 25. We got 3x cubed minus 7x squared plus 14x minus 25. And we had a remainder of 30, so we have plus 30 in the end. So again, this was our polynomial, this was our divisor, this is our quotient, and this is our remainder. Yes? If it's so long that you make it equals and you write underneath, that's fine. Okay? Again, what we're leading up to with this division statement is eventually we want to find ones where this remainder is 0. And if that remainder is 0, you've started to factor. And then you'd have to figure out, oh, what would be the remainder 0 for this one? And then we start to factor that one. And we're developing a technique so that we can factor more complicated things. Okay, so the ones for this are 3b and 7, and we are going to work on the questions from the first part and the second part right now.